All right, page 2. Use synthetic substitution to evaluate each function. So here is my value, and that's what goes on the outside of the synthetic box. And then I have to think about my coefficients. I have to check, first of all, that my polynomial is in standard form with descending powers, and I want my coefficients, so 6 and -1 and -16, and I need to have a 0 placeholder for my constants, and this here is going to be where my value is. So I bring down 6. 2 times 6 is 12. 12 and -1 is 11. 2 times 11 is 22. 22 and -16 is positive 6. 2 times 6 is 12. And I have 12 as a result. All right, let's look at this one. Synthetic substitution to evaluate x is equal to 4. So 4 is my value outside my synthetic box. 3, 2, 1, none. So I have 2, -2, 1, and 1. And this box here will be what my solution is, not a 0. Wishful thinking. All right, 2 comes down. 4 times 2 is 8. And I'm left with 6. 4 times 6 is 24. Plus 1 is 25. 4 times 25 is 100. So 101 is my solution. Coming back here, that means that a 2 as an input gives me a 12 as an output. That means 4 as an input gives me 101 as an output. All right. Use synthetic division to divide. Here we go. Now I'm dividing. If x minus 2 is my factor, that means that 2 is my solution, and that's what goes in my synthetic box. Here I have x cubed, no x squared, so I need a 0 placeholder, and 7 and 6. So 1 comes down. 2 times 1 is 2. 2 times 2 is 4, 11. 2 times 11 is 22. So I'm left with 28. Therefore, my answer is x constant linear squared plus 2x plus 11 plus my leftovers out of my factor. All right, next up, if I'm dividing by x plus 1 as a factor, that means I'm testing x minus 1 as a solution. Minus 1 on the outside of my synthetic box. And I go ahead and, I need to make sure my polynomial is in standard form. So 4x to the fourths come first, then 5x cubes, then 2x squareds. I don't have a linear term and a minus 1. So 4 is my fourth degree, 5 is my third degree coefficient, then 2, then 0. Remember I had a 0x and a -1. And I'm looking for whether it divides evenly. All right, 4 comes down, -4, 1, -1, 1, -1, -1, +1, 0. Hey, that means that this is a factor. That means that it divides evenly in 2, and I have a constant, linear, quadratic, a third power, a cubic polynomial left over. Here's my cube, there's my square, here's my linear, and my constant terms. All right, next up, determine if the given binomial is a factor of the polynomial, so shows synthetic division work to support. I'm testing, is x equal to -3 a solution? 3, 2, 1, none. So I can put my coefficients in. Now, if it is a factor, this should be 0. Let's see what we end up with. Bring 2 down. -6, 5, -15, +3, -9, 0. Therefore, yes, x plus 3 is a factor. Alright, now I'm testing x minus 3, which means that x has a value of +3. We're testing that in our synthetic box. 3, 2, 0x squared, linear. So I have 3x cubes, 0x squares, 8x to the first powers, and constants. 3 comes down. 3 times 3 is 9. 3 times 9, 27. Oh goodness. 3 times 35, 3 times 30 is 90, plus another 15. Sounds like 105. So it sounds like I have 98 left over. Therefore, no, it's not a factor. Okay, now my job is to find all the zeros of each polynomial. Show synthetic division to support your answer. So here's where I need to get out my graphing calculator, because my first step is to figure out where those zeros might be. Alright, so we'll clear it out, go to y is equal to and clear that out. And we'll go ahead and say x to the third power plus x to the second power minus x plus 15. So we'll go ahead and graph it. My stat plot is still on. We'll have to go fix that. Looks like we might have a 0 there. Let me turn my stat plot and my data off. Graph again. Alright, so we're looking for an answer somewhere at -3. Oh dear. Table set will start at 0. Look, there's my 0 right there. Okay, so now that I know that -3 is a 0, I'll go ahead and put -3 in. Remember, if -3 is a 0, that means +3 is a factor. Okay, here's my cubic, quadratic, linear, and constant terms. Now remember, I'm hoping for a 0 here. Otherwise, I've screwed up. 1 comes down, -3, -2. Let's see, this makes +6, +5, -15. Yep. So that leaves me with x squared minus 2x plus 5 is equal to 0. So you know what? I think I'm going to complete the square for this one. So we'll go ahead and move 5 out of the way and think about, what do I want in here to fit this pattern? Half of -2 is -1. -1 squared is 1. And this would be plus. So we'll add +1 to each side, giving me -4. When I take the square root of each side, I get x minus 1 is equal to plus or minus 2i. X is equal to +1 plus or minus 2i. Alright, so when we go to list our solutions, sorry about that. We go to list our solutions, that means that x is equal to, this 3 comes first, and then 1 plus or minus 2i. Here's my 1, 2, 3 solution.